So good morning all of you. This is me, Adnan Ghori, the founder and director of iWorkstation. I welcome you all for the iWorkstation BIM series week 10. So I would like to introduce you Pawel Laguna. He's a digital construction advisor. He's also a registered architect. He is currently working as a CTO in Graphit, managing complex projects, implementing technological advances on various stages of the building life cycle, including parametric design, BIM, common data environment, computer-aided facilities management, and Internet of Things solutions. He has more than 8+ years of experience working in Poland on different projects of BIM. So I would like to invite Pawel Laguna. Yes, Pawel. Welcome.
Thank you. Thank you very much. I'm really happy to be with you all. Thank you for the invitation once again. And well, shall we start or do we still wait for other participants?
We can start the session, Pawel.
Okay, good. So I'll just share my screen and we can kick off with that. Okay then, can you all see my screen well?
Yes, it's clearly visible.
Good. Yeah. So let me start with saying that typically I would tell people about BIM, about the database, about everything that is connected usually to the building information modeling. Today, however, because I know that you've already had some sessions covering that, I would like to talk about some of the projects we are doing, and the projects are concerning, in fact, city information modeling, mainly urban structure and urban infrastructure. So instead of talking about city information modeling, we'll be talking about city information management, because some of the things I'll be showing you are not typically related to strict BIM activities in terms of, Revit use or ArchiCAD use or Tekla use. So as Adnan said, I've been working on different projects for different clients, both in private and public sector. We've been doing projects for Poznan City, for Ministry of Foreign Affairs, introducing some developments in digital building, introducing BIM, of course, but also introducing, as Adnan said, common data environments and other interesting technologies, but also processes. Processes are really important for us because, as I say, building information modeling is becoming building information management. So whatever you do with information, if it's structured, if it makes sense to more and more people, it's still BIM for us. So I'm also a lecturer and postgraduate and MA studies. In fact, I'll be doing some lectures later today. So I hope that you will enjoy the presentation, and I'll be happy to answer all of your questions. Just to kick you off, I'm privately very interested in algorithmic design and parametric design as well. I understand that parametric design is the beginning of BIM. I mean, if we are thinking about designing in this case urban structure, we can devise some algorithms to optimize and to develop better urban structure, more user-friendly urban space, if we use objective parameters that we know suit well the environment. So just to start you off with the infrastructure, you basically know that building industry is not effective enough. So McKinsey & Company, you probably know McKinsey & Company, they are the organization who prepare reports covering different branches of different industry sectors. They also do some reports on building industry. They've published in 2017, I think, a huge report called Reinventing Construction. And one of the guys from McKinsey said that we are potentially losing $1.6 trillion a year because of the insufficient effectiveness of the sector. So let us think, what can we do to make that different? So we'll be covering today parametric urban design. We'll be covering more precise and more, let's say, detailed design, covering building concepts. And lastly, but not least, we'll be talking about city infrastructure, which is really, really important, not only for us here in Poland, here in Europe, but also for the people all around the world, because urbanization is making city infrastructure ineffective, and we've got to work towards making it more and more efficient. So let's start with parametric urbanism. What we do, I want to talk about our workflow, how we design urban structures, urban spaces. So basically we begin with GIS analysis. GIS, as you probably know, is a geographical information system, which was based on 2D data enriched with metadata. So you've got basically some parameters like in Google Maps, and they are all geo-referenced. So we are using S3 software ArcGIS and also we devise scripts of our own to acquire different information concerning well, different amenities, different functions, different urban functions around the city, but also connectivity and well, the hubs that we need to, to prosper in the city and to design proper urban developments. We are gathering all this data. We are dividing it into voxels. Voxel, if you know, it's you can compare it to a pixel on a 2D drawing, on a 2D image. So voxel is a 3D space, a minimal 3D space, which we can then import into our authoring software as a, let's say, base for future design. So we prepare those analyses. We turn them into CSV files, we turn them into text files to import them into our algorithms. And this GIS matrix, this GIS matrix, in this case, let's say we are looking for hospitals around the area we are designing. Why? Because we want to introduce healthcare function in our urban space. So what we do, we are checking not only where are the nearest hospitals, but we also are checking the parameters of those hospitals. Let's say the number of beds, or let's say the opinions about the hospitals or other healthcare centers around our development. And that is how we can establish if certain functions are needed, and let's say tell the algorithm to wage proper functions with proper parameters into our urban space. What we do then, we are introducing parameters and we are introducing algorithms. In this case, this is an algorithm devised by Professor Reinhard Koenig. I mean, this is the part of the algorithm. This has been devised by Professor Reinhard Koenig. And we've been playing around with this algorithm to devise a fast way to design urban space. And this urban space, as you can see, is divided into different functions, because probably, as you know, the monoculture urban spaces are out of date. People want to live in neighborhoods where they can use different functions, and different functions are intermixed.
Is it the grasshopper, Pawel?
Yes, go ahead.
Yeah, it's from the grasshopper, right?
Yeah, we are using different tools. I should say that this is in fact Rhino, and the algorithms are done in Grasshopper, okay, with some nodes, as I said, devised by sometimes other people, but also we are scripting as well, and we are adding into this on our own. But this is basically just the same when we use Revit and Dynamo tools for that, because depending on the project, depending what problems we are facing, we are using different tools, which I'll be talking about later on. So As I say, we are using these algorithms to optimize the space, to give various solutions to our client, because we believe in choice. We believe in informed decision making based on the parameters. So we are starting with BIM right from the initial ideas, which we are trying to make as parametric as possible, so that we can then objectively analyze the structure. And what you are seeing right now is the design space. The design space is the let's say the range of all the solutions which has been generated by the algorithm. We sometimes use genetic algorithms which are basically trying to find the most optimal solution, maximizing or minimizing one of the or two or three of the parameters. So what we are seeing here on the bottom of the screen, you see several of the solutions generated from the algorithm creating the urban design, urban structure. What you see up here, these are the parameters. On the left, these are the parameters which were going into the algorithm. Let's say the grid of the streets. This was one of the parameters. Let's say the maximum length of the elevation. This was another parameter. And on the right, you've got parameters that are output of the algorithm that we are trying to measure. Let's say the maximum usable space of all the stories of all the buildings. Let's say that one of the output parameter is the area which is shaded, because we obviously, when we are designing housing districts, we want to avoid shading too much of the elevation. So based on these parameters, we then try to select the most optimum solutions. How do we do that? We just narrow down. This is the screen, the snapshot which I'm showing you is just one of the tools. It's called Designer Space. It is an open software. This is a web platform, so you can upload your data in as JSON files together with some CSV files, which is defining all the parameters, and the software, the platform is visualizing it for you. And then when you narrow down the parameter domain, just as I did in here, instead of getting 100, 300, 1000 solutions, I'm beginning to get the optimum solutions based on this narrowing of the parameters, right? So let's say the client wants to maximize the area, the usable area, the usable living area, but this maximizing gets other parameters so low that the area is not interesting for the users. So then we can just play around with those domains so that we can get optimum solution for our client, but also for the future users. This tool gives us the ability to objectively make decisions concerning really huge investments. And this is BIM for me, because we are all, you know, designing with information. The 3D model is just, you know, is just an add-on for the information we are gathering, right? So if let's say the customer, the client, wants to be sure that the development he is doing will meet his requirements, then and only then he can choose one of the options, a 3D option, right?
So Pawel, is it also like Project Refinery or something? Project Refinery also has these options, right?
Yeah, it is, exactly. So also Autodesk is providing some options for these kind of solutions as well. You can export data from Dynamo. You can use Forge API to publish it in the net. This one is just a really simple tool based on JSONs, which you can easily export from both Revit or Rhino, and CSV file, which is also a really basic basic format. So we like this this solution because we can also publish it to our clients. He doesn't need any special equipment. He doesn't need any special knowledge. He just gets what he wants, and we don't even need to be in his office to check all the solutions. If we have time and if you have questions, I can switch my screens later on and I can show you how the solution works online, right? Because I've got this data prepared for you. Okay, what we do next, we basically connect the models we are doing. This is another project, and it's been done in Revit, as you can see, using Dynamo as well to distribute function blocks around the urban development. But these urban blocks are already connected to the Excel file. What we experience more and more is that developers, our customers, not only want to see pretty pictures, but they want to give data to their analytics to check if the pretty pictures are really what they need in terms of functions, in terms of the topology of functions, in terms of the topology of space. So what we do, we connect usually either through just, you know, scheduling the things we've got in the model, or through Dynamo, we connect our models to Excel files, and we send those Excel files together with some visualizations to our clients so that they can play around with those Excel sheets, sometimes introducing new data, sometimes changing the data we already have, sending us back those Excel sheets, and then through Dynamo we are importing those parameters back into the model, checking what are the consequences of those decisions. Let's say the client wants to make the apartments more, or make the office space more premium. Then he just plays around with the Excel file. He changes the cost per square meter of the office space, and then the whole development costs a lot more than it used to. So these are the parameters we are checking out. These are the parameters that we are providing to our clients so that they can play around with them, right? And also we believe that only, as I said, informed decision making makes sense for our clients. So we are also preparing workshops to work hand in hand with our clients, so that they do not feel, you know, abandoned with all this data. So basically, this is also from Rhino. This is there's been some scripts, some nodes used from Proving Ground. This is a developer of one of the developers of nodes for Grasshopper, but they are also developing nodes for Dynamo as well. So what we are doing here, we are preparing a workshop that shows the client live the basic information about the structure, phasing, and urban design of the development. So when he wants to check what happens if one of the buildings gets bigger, when he wants to check how the investment will be balanced if we change the, let's say, the outline of certain building types, then we can show it to him pretty fast, and he can react to those changes, you know, by seeing the results and by being informed what are the consequences. So as I say, this is BIM. This is basically information management right from the start, because the parameters we are checking up are also concerning the city infrastructure, the length and the width of the streets, the basic functions that need to be provided. And this is how we are using this GIS data as well in the algorithms. So then we are visualizing the models. Because we are working with 3D models, the visualizations are pretty painless. We use basically Lumion for that, or V-Ray for that, but usually Lumion, because this is the fastest and easiest way to update the models using, for example, sync in Revit. So every time we change the model just a bit, we can update it in Lumion and provide new visualizations in terms of, couple of minutes. Sometimes because the material is already there, the greenery is already there, the people are already walking the streets. So this is basically a really good workflow to, to communicate our design with our client. Have you got any questions so far? Do you think, Adnan, we can do a short Q&A session now, or should I proceed with building concept?
You can proceed with the concept, Pawel, and
okay.
later in the next session we'll take the question answers.
Good.
Yeah.
Good. Okay, so basically, when we do this urban design, there comes a time when we need to focus on one or more buildings. So we are also trying to devise algorithms to optimize the building functions, the building plans, the building spaces in the buildings. So what we do, we are trying to make those space relationships more objective. And how do we do it? We formalize the functional relationships into graphs and matrices, either just in Excel. Let's say, imagine that you need to design a hospital, or you need to design an airport. Then you've got certain functions that need to be in certain relationships with other functions. Let's say a patient room needs to have a close relationship to the doctor room, right? So we are formalizing it into graphs so that our algorithms will understand our intent and try to, let's say, distribute those functions as close and best as possible, right? Because if those functions, as you can see on this graph, for example, are multiple, they are really hard to understand and to distribute, in optimized fashion just by one human, right? So we are using, again, Dynamo or Grasshopper to test different solutions, maximizing or minimizing crucial parameters. And then when we get those optimal few solutions, we are then evaluating them in BIM authoring tools such as Revit, ArchiCAD. So basically what you see on the screen is one of the projects. The project was a bit complicated because the customer wanted to have a building that will be flexible enough so that after a few years, the main function of the building will be different. And not only this, but also the functions in the building were totally mixed. There was, there were offices, there were laboratories, there were common spaces for brainstorming. There were also apartments there as well. So this was kind of a showroom building for a concept, for a bigger concept. So we needed to devise an algorithm that will not only distribute the functions for the first iteration of the building life cycle, for the first, let's say, generation of functions, but we also needed to design some mechanism to redesign the building later on. In terms of the structure of this building, we just devised a really basic structure, flexible structure that could, inhibit all those modules which would eventually be changed as the years passed. So the algorithm really helped us in providing this method. When we do these optimal solutions, we are analyzing them through different add-ons and different algorithms for, let's say, in this case scenario, shading of the elevations. We do have a tool that can basically tell you up to few minutes how long the sunlight will be penetrating one of the windows. So of course Revit and other softwares do have those solutions built in, or They are just a part of the package, of the bigger package. But due to the really strict building code here in Poland, we needed to devise something more to, let's say, to compare those building codes regulations to our design. So this is really important, especially here in Poland, here in Europe, in fact, where you have got a dense city neighborhood, to provide proper conditions for the people living and working in the buildings. And that's why we are trying to let's say, check those conditions on the earliest stages of the design. As I said, I won't be talking much about developing BIM projects in terms of, doing execution design or building permit design, because this is something that was probably covered by other guys, and this is, let's say, in the mainstream of the building information modeling community, how to prepare building permit design, how to prepare drawings, how to export them, and how to communicate them to our clients. But what I wanted to say is that those solutions that we are using, like, for example, Design Builder, which is not that perfect. When people tell you, for example, that this integration with let's say sustainable design or CFD, computer fluid dynamics software, is instant, right? You've got BIM model, then you can instantly somehow magically integrate it with other software. It's not that simple, as you probably know, and that's why it's a hard work to prepare those models properly, and sometimes even rebuild them in the dedicated software. But we try to do it early on during the design stages, so that we can control the conditions that our users will be facing. So this is just a visualizations to show you how we communicate those sometimes difficult topics like sustainable design, like using the different means of supporting energizing the buildings and so on. So we do this analysis of the eco potentials, as I said, in different dedicated softwares. As I said, the integration is not that simple as you might think from conferences and from the software developers that are trying to sell you these softwares, but nevertheless we do it anyway to provide better environment for our future users. What we do with our models is also analyze them in terms of some basic things like areas, volumes, materials used. Also, as we are trying to check the processes that are being conducted when building those databases. We want to check, for example, how many collisions we are having throughout the process. Do the collisions really are really solved, or are they still there? So we are using, for example, Power BI to visualize those data. Okay.
Yeah, we can proceed.
Okay, good. So as I said, we are basically analyzing the models we are doing in terms of this documentation I've been talking about. In fact, that I have not been talking about, because you all know how to do BIM documentation from Revit or other files. There are some markings on the presentation. That's okay. Okay then. So these models are being analyzed in Power BI usually, or just Excel files. What we do is get the data sets from Revit or from ArchiCAD or from any other software we are currently using, and either we push it through just schedules formatted as TXT files and then import it in Power BI, or we use Dynamo for exporting Excel files, which we then which we then incorporate into Pawel BI, so that we can understand both our buildings better in terms of area, volumes, let's say glazing surfaces, let's say materials we are using, how the materials are affecting costs of the building. Also, we are trying to control the process. So we are also integrating in the Power BI in the Power BI platform. We are integrating things like collision reports, collisions, how many of them have been eradicated throughout the process, and so forth. And also, we are providing these schedules and costs, these dashboards to our clients, so that again they can make more informed decision based on the data they're seeing. Because usually, the traditional way of designing, they see the outcome, that the building or the urban structure or the infrastructure, but they do not really know what is the most cost affecting element of those buildings. I mean, if they're experienced enough, if they have a lot of knowledge concerning building structure, concerning building workflow, they usually do know what are the most costly factors, but not always. Sometimes these are things that are not easy to spot just by looking at the design. So that's why we prepare analysis. So just to cover up the process, just to sum it up, we start up with the definition of basic parameters. We are determining what are the local conditions, what are the local urban law parameters. We are determining the minimum spatial requirements, and also the urban structure. We're designing and developing those functional blocks, which then will be needed for the whole structure to be constructed, right? Then we use data. We are data matches of functions both in the urban space and in the building. We are using ArcGIS Pro for that. We are using FMI to integrate BIM and ArcGIS into BIM. For this as well, the best friend of the BIM manager, in my opinion. So you should really should be used it as much as possible, because it really helps during the workflows and during the processes a lot. So then we are incorporating this data into our models, introducing functional relationships, generating the border conditions in the model, and then we are using sometimes other algorithms to find the best solutions for our projects. And then we are visualizing and analyzing these optimal solutions through analytical software. As I said, this might be plugin in Revit, this might be Dynamo, this might be Power BI, but this also might be a design builder or application, other software for analyzing 3D models. And last but not least, we are trying to some verification in the BIM authoring software. We have and verify them in terms of the building code, in terms of real needs. Sometimes the algorithms are giving us a lot of strange information, strange solutions, and that's why we need to evaluate all those stages through informed verification. And if the verification is negative, then we need to go back and either redefine basic parameters or redefine the algorithm itself, or use even other algorithms if the solutions that have been provided are not enough. So basically, this covers those first two modules. If you have got any questions, please go ahead and ask them now, and we can then proceed with the last module, which will be about city infrastructure. I have also one question to any question then? Or
Yeah,
shall we?
Pawel, I have a question to you. Yeah, when we work with the BIM and GIS integration, so how can we add the attributes to an information model that is being made in a Revit tool or a ArchiCAD tool, and that those attributes can be visualized in the ArcGIS software? So how is it possible? Is it possible to retain the information that we integrate through the ArcGIS to Revit or ArchiCAD?
Oh, definitely, definitely. There are several methods for that. In fact, there are so many that I will just focus on the workflow we are doing, because there are so many methods for that. And on the other hand, we want to have a complete control over the parameters we are exporting from Revit into ArcGIS and then into GIS platforms. We are using FME software. This acronym is short for something, but I really do not remember. But if you check FME, you will.
Right?
Excuse me?
Yeah, that FME exporter is from the SAFE company, right?
Right. Yes. So we are using those. We are using this tool to export BIM models from Revit, and they are basically using the API of IFC export. So all the information you can export through an IFC file format will be integrated into ArcGIS as a flattened list. This is a problem in terms of, the segregation of the information, but as a first step of integrating all the data that we need, and then going through this data and choosing which data we actually need in ArcGIS and which data is really not that important in terms of integration BIM with GIS systems. This is I think a really good platform for that, because we do have control over the import, we do have control over the export, and we do have control over which parameters are then published.
Absolutely. And suppose there's one more question I have related to this same previous question is, like, suppose we import the information model into the ArcGIS through FME exporter, fine? Then how can we bifurcate or filter the different parameters of a building? Example, suppose I have to filter a room in the second or third floor of the building, like its size is like a room of a lesser size or a room of a more size of the area. So can we filter it down, and how is it possible? Is it through attributes, or we have to define some other constraints or parameters in ArcGIS?
I'm sorry, because there was some some bad audio I got from you. Could you please repeat, because I've heard only that you want to export a room into ArcGIS, right?
Right. Export the entire model into ArcGIS, and in the model itself we have different rooms. So suppose I want to identify like a room of a smaller size or a smaller area, or a room of a larger size or a larger area in the third or fourth floor of the building. So how we need to define those things? Do we need to define the layers, or do we need to define the constraints or set of filters for it, or do we need to do the coding in it? So how can we do that?
What was the third option you've been asking for? The third one.
Third one was the coding.
Yeah, so basically we can export areas as in for example, you are exporting IFC space, right? So you can integrate this data into the layers, and then you can just push it through ArcGIS. So yeah, I would probably use layers, but this is just so many ways to do it. Then that I really would have to have the model itself, and then to show you on or have a case study, and then to show you the whole workflow. As I said in the beginning, if you need such detailed information or such detailed workflows, I'll be happy to prepare a presentation live on one of our models and to show you one of the workflows, because as you can see, I've been showing you 2 or 3 or even 4 workflows so far, and they all are, you know, custom made and tailor made for the project itself. As I say, I can only advise on some of the tools we are using because I know that they work. Give those possibilities to tailor made the solution for us, right?
Yeah, there's one more question from one of our participants named Narendam. His question is, what is the criteria of diving the whole site? How did you build relationship, and how do we set agency and proximity?
What was the last element you've been asking?
And how can we set the agency and proximity?
And proximity. Right. Okay, so what we do in this case scenario where we've been checking out the proximity of certain functions. So basically we start with GIS and we import the data as a geo-referenced data set. So basically in the model itself needs to be geo-referenced. So when you have a geo-referenced model, then you import this GIS data as a data set which has X, Y, Z parameter, obviously, and also another parameter which governs the proximity of different functions around the area we are talking about, right? And that is how we receive a kind of point grid with different values. I don't know if this is clear enough, but you can imagine a point grid in a space, and each point, just as in a point cloud, has X, Y, Z parameter, but instead of color, when we are talking about a regular point cloud, a TLS point cloud or photogrammetry point cloud, we instead of color, we have the value of the proximity of certain function, right? And then in either Grasshopper or Dynamo, we can relate to these points, checking how far or how close are we to the certain function, right? So this is the base. This is the base with which we are starting. In this case scenario where we had this hospital, this one point had more than one parameter. There was this parameter of proximity, but there was also this parameter of how good the function is, and so on and so forth. So this is the start. But then when you want to check, for example, the space plan, the proximity of different functions in the building, for example, you need to measure in different algorithm options, when the algorithm gives you different variations of the same space structure, of the same plan, right, of the modules, when he distributes the modules more or less randomly, right, at first. Then you measure the proximity of each and every module and check for the solutions where the sum of those lengths between those different proximities is the smallest. But to make things a bit more complicated, we introduce those graphs, as I said, to check if the wages of the proximity are also taken into consideration, because some areas need to be closer to each other than others. So that way, not only we are checking if the certain function is close to each other, but also we are checking if those areas that are close to each other have higher wage than another option. I don't know if that, again, this should be done as a live tutorial or some live case study where we can show step by step how we do it. But obviously, in terms of 30 or 60 minutes, we do not have enough time. And I hope that you will understand the basics and you can go from there, or I don't know, join some other sessions, right?
Okay, but and there's one more question from Kunal
Sir,
Pavel.
I have one question. Okay, so I have a
Yes,
question
Kunal.
that how can we work to how can we work with BIM and GIS integration, and if there any procedure or any steps that we can refer or that we can learn from them, so can you share with us?
If you could repeat just the first part of the question. You mean you were asking about integration of BIM and GIS?
Yeah, BIM and GIS workflow integration means how can we work together with BIM and GIS?
Right. So as I said previously, we are using for this FME platform, but basically the workflows are really different depending on the project itself. So basically the easiest case scenario, you want to introduce model into GIS environment, right? What you do, you have got, let's say, a Revit model. First thing you need to do is to properly geolocate this model, and you do it through defining survey and project point properly. So you get the coordinates in the proper coordinate system from a GIS platform. You copy them into the survey point, into the project, into the survey point. This is the most so that the shared coordinates are the same as in the coordinate system that you are looking for, right? So then you introduce these coordinates, but you also need to have an exact point of introducing the model into the GIS platform. So how we do it, usually we do have these maps, which are in fact law. You need to get those maps from the proper authorities, and those maps have those crosses, yeah, like geodesical crosses, which define the exact point with exact coordinates. So we use these coordinates to propagate throughout the models and throughout all of the platforms we are using to create those models, right? So you do have the point of insertion of the model into GIS. And then we use FME platform, as I said, but there are really different solutions. You can easily export Revit files without FME platform as well. Just make sure that the geolocation is proper and that you are using this GRI, I think that it's called GRI format to define the exact point of insertion, because GIS platforms sometimes, even when you do have geolocalized your model, are going crazy with the coordinates. So you need this additional file format to really be sure that the model will be in the place you want. Otherwise, you can use platforms such as FME. There are other platforms that can translate, for example, IFC models into GIS. So then you need to make sure to incorporate all the data that you really need. As I said, for example, this FME platform lets you choose if you export. Basically, it's like an IFC export, but the file format is different for the FME platform. But basically, you can export all the parameters, all the schedules, as if you were exporting IFC file, and then, not to make the model too heavy, you can delete, or you can just not publish some of the parameters into our GIS format. So this is the easiest case scenario where you just want to integrate your BIM model into GIS environment, and I think that this is the proper way to do it, because I'll be talking more about infrastructure. I think that it's time to so we can carry on with the last
Sure.
slides, and I will show you how those integration, BIM GIS integration, work for us in favor of our clients as well. Okay.
Sure.
Okay then. So I wanted to finish up with city infrastructure, because as you know, the budgets for city infrastructure, the budgets are really high, and the needs for city infrastructures to be efficient are really high as well, and the people, the city users, are demanding more and more efficient city infrastructure. On the slide, you can see the work we've been doing for Poznan City. As you can see, this is an old town of Poznan City. The history of this place is about 600 years old. So the first settlements were introduced into the area around 15th century. So what we wanted to do before conducting some modernization projects, the city wanted to make sure that both the maps that they have are up to date, and usually, I must admit, they are not. So basically the pipelines, the underground infrastructure is somewhere else than the maps tell us. This is a huge problem in terms of realization of the works. So first what we do, we need to link various data from various survey devices. Some of them are non-destructive. Some of them, like drilling, are obviously more invasive. But how we start those infrastructural projects, we start with proper survey. And this is also BIM. I mean, you cannot design anything, you cannot integrate BIM into GIS if the data you are having, even the GIS data, because GIS data is obviously less detailed and less accurate than the BIM data, but you cannot integrate those designs properly if you do not have a precise information about what's going on, not only on the surface. So you do have those laser scans and drones and everything, but you also need to know what's underground, because the standing joke is that the money is underground, right? When you strike a pipe, when you strike some unfavorable soil conditions, then your project faces a huge problem, right? So we are using some geoscanning methods, right? GPR, this is ground penetrating radar. We are using electrical resistive tomography. We are also using drilling, but also we are acquiring data from open source data platforms so that we can prepare the initial model, the inventory model, and then we can model on this base so that our projects are, in line with what's really there. What you see on this picture, these strange structures over here, these are unidentified objects. I mean, we've detected them through different means of surveying the ground, and they are not, articulated on any of the maps. So basically, this is a catastrophe waiting, because when the general contractor starts digging, you can be sure that he will claim additional money for removing those things. On the other hand, when you prepare general contractor through giving them a proper BIM model, which also consists of those elements, then those claims are not valid, right? So our client is happy because she doesn't have to pay, right? So infrastructure models, as you can see, we use different tools to do the survey. As I said, LIDAR, scans, UAV surveys, when the areas we want to scan are inaccessible, right? Geoscanning, as I said, different methods. This is another project conducted in one of the cities in Poland, where we surveyed the underground infrastructure, and then we were supposed to BIM the 2D documentation to check it, because the documentation of this modernization of this whole area was conducted traditionally in 2D drawings, and you can see how many things are underground over here. The funny thing, once again, are these elements over here. I can show you in better contrast. Those green things that you can see over here are detected old foundations, because before the Second World War, the buildings were a bit further on towards the axis of the street. So had we not found those elements during our surveys, had we not modeled them into the model, and had we not checked the design, and the design itself had many clashes as well, and after we modeled all those infrastructure and the terrain and the pavements and everything, so it happens it had many clashes. So we also you know, resolve those clashes as well. But had we not done it, the general contractor responsible for conducting works over here would surely claim a lot of money. These are millions of Polish zlotys, these are millions of dollars, right? To for those additional works which were not ordered during the procurement phase. Okay, so this is the design verification. As I said, BIM comes whenever you want it to come. In fact, sometimes it comes right from the start, right from the initial design, right from the initial concept design. But other times, as in this case, BIM comes as a tool for verification of the documentation done traditionally, right? Because of many mishaps during the construction works in our cities, our local authorities have decided, not all of them obviously, but some local authorities have decided to check the documentation beforehand, before procurement, and later on carry on future design within BIM environment right from the start. But as an initial phase, because as you know, BIM is not incorporated as a you know, legislation here in Poland, so we are facing some problems introducing BIM into the wide market, probably as everywhere. So as an initial phase, sometimes we need to BIM to model the execution design to show the value of BIM. The funny thing was, when we showed the report of those clashes and discrepancies in the documentation, in the building permit documentation to the authorities, the guy who was not an engineer, he finished some economical university. He said, okay, now I do not need you guys, I can coordinate it myself, right? It obviously it is not true, but imagine this manager who is seeing 5th or 10th or 15th project on the 2D drawing. When you see this grid of different lines and different elements and different annotations, you do not really understand what's going on. I do not have to tell you more about BIM, obviously, but I want to tell you how important this is for laymen, for people who are not engineers, to see it and to really you know, acknowledge the value of BIM for infrastructural projects especially. So BIM GIS integration, as I said, we are conducting huge infrastructural projects here in Poland, but also in Europe and other parts of the world. And when we do, we are designing, for example, whole segments of roads or rail infrastructure, but then we want to see it in a wider context, and that's why we are integrated this BIM project into GIS. And this obviously gives us ability to visualize and animate those projects for public consultations, because you see, when we are introducing such a huge project into the neighborhood, people are really reluctant. They do not want this investment done because their green backyard is turning into a highway, right? So visualizing it and showing it to the people sometimes lets them know that the area will still be safe, the area will still be green, but the pros of these solutions are that the transport will get to, you know, to their doorstep basically. So this visualization and animation is not a small thing. Sometimes this PR, let's say, element sells BIM, and BIM GIS integration sells it even better. So also when you are introducing this huge infrastructural projects into the city, this BIM GIS integration lets you validate your design, right? Because you can see your design in context. You can avoid such stupid mistakes as misalignment of the certain elements, right? Also, those BIM parameters can be and should be incorporated into City GML and into GIS platforms, so that people, when the models are published, they can see the parameters. They can, for example, check if the bus stop will be good for them. I mean, if the buses that come in the neighborhood are the ones that they need, for example, yeah, right. It's just an example of how you can use this BIM data and integrate it into GIS. So integration with GIS platform is really important, and you should integrate it, especially in terms of infrastructural project. This GIS integration also gives you an access to the mobile services and web services, because, as you know, GIS services are light, so you can basically browse through them even on your cell phone, even on your mobile device. And also, I want to stress that this is really important. In such huge investments as infrastructural projects, there is nothing more important, sometimes even more important than a really detailed BIM model. It's common data environment platform. When you are having such a huge investment, such a huge number of participants, such a huge number of stakeholders, common data environment, and access to the BIM model through common data environment is really important. You cannot expect all the participants, all the stakeholders of the project to be able to open your BIM or GIS model on their desktop. They simply will not do it. They simply will not install additional software. So that is why it is so important for a complicated, huge projects to introduce common data environment, to properly design the process of communication, which you obviously already know probably from other lectures, how much information requirements, employer information requirements, virtual city platform for Poznan City, and we've conducted quite a few projects there, so we've been able to incorporate BIM models into this virtual city platform to enrich some of the layers and to enrich properly some of the elements in the virtual city model. I'm not sure if they're already public, but they will be probably soon. So basically, those virtual cities are getting more and more popular. There will be a platform for exchanging ideas, storytelling. I think in the future there will be a platform for communication for communities, but there will also be for businesses to evaluate their design and to evaluate their ideas. So really big thing about BIM GIS integration coming up with more important in the future, I believe. So our process, once again, server data acquisition. When we start our infrastructure project, we usually start with deep surveys with really stability. This is great, so that all the measurement taken within the GIS system. We do geoscanning, we do some photogrammetry, we do laser scanning, we input data from the platform. We once again use we do fieldwork, obviously, with different tools to get and interpret the data. We can process the data. Let's say use compare or now data GPR slides for GPR. measurements and others of the you have other steps as well. You use Civil 3D to prepare the data, embed the data, so that we can then incorporate the data into the platform. We use Dynamo because of the data we are getting, we are preparing it just as a vector drawing, 3D vector drawing, and then, for example, in Dynamo, we can send this vector drawing into regular applying system, into regular industrial. So instead of modeling this whole infrastructure, we are using Dynamo scripts to translate lines and polygons into MVP systems. So then we will have parameters needed. Sometimes there are more parameters depending on the project, depending on the client. So there are more parameters. Sometimes there are basic parameters concerning how, what is the diameter of the infrastructure, the other infrastructure, what's the potential usage, what's the system, and so on and so forth. So then we analyze, visualize all those models. We resolve any clashes that are in the models. We generate documentations. From the times we are preparing visualization animations. We use names manage for that. We use Power BI. We use sometimes some viewers to provide data to our country. It's also an important thing to be able to communicate our models. Our customers need to provide them with free solutions so that they can invest in any advanced software because they obviously not use it. So we use visualization usually and for animations, and then we design the infrastructure itself through creating designs of the infrastructure. Execution, we obviously help do the execution of works as well, keeping really post-execution stage and end phase. So we use other software like AutoCAD 3D, Usenet, we use adding tools such as single beam, for example, models for the export for the publishing. I can do ArcGIS and any platform with the software, and obviously, last but not least, definitely use some platforms for the difficult and complicated projects. And even if the customer doesn't want to pay for it, we usually use the basic template environment so that at least we've got one source of information going around and in the process. So it's complexity, right? So our cities are getting more and more complicated, our environment, our building environment are getting more and more complicated, so the integration of different kinds of data, you can recall GIS data, but you can also recall data which is being incorporated into this Bible Grasshopper script. This is a really important thing to have in mind creating BIM database. So this is it for me. If you have any questions, we still have probably a few minutes. But as I said, yes, I'll be conducting some lectures later on during today, so I haven't got too much time, but please go ahead with the questions you have.
Yeah, Pawel, I have a question for you. Like, if someone is just starting his career in the GIS and the BIM, so what do you suggest to that person? Either he or she should take the education, or he or she should work in a company to gain some experience. What do you suggest to him?
Well, basically, the knowledge about BIM and GIS, I mean, this workshop knowledge is accessible through internet, right? So obviously, it's better, it's more efficient, and it's usually easier to get a formal education, to get on some course and you know, and learn about BIM from the course, because obviously people who are lecturing know a lot and they've covered a large scope of projects, so they can easily and you know, quite fast teach you the most important things, because when you start teaching yourself, you will be faced with a lot of data, that is just trash, right? That is just not really for you. So basically, I would advise some initial course in the topics you are really interested in, but then I would really advise a quick employment in a firm that is doing stuff like this, because until you get a hands-on project, hands-on approach, you won't be able to grasp all the details of the workshop knowledge you just need.
Right. And actually most of our participants for these iWorkstation BIM series sessions are basically from India, right? So India is like they are also focusing more on the infrastructure development, but I hardly see any of the people or the professional companies or professionals working towards city information modeling or working on GIS or BIM integration. So what do you suggest towards like the development that is happening in India? Because it's gonna happen, and there's a lot of projects being coming up and planned nowadays for the infrastructure. Yeah.
Yeah, so the question was, what do I suggest for the professionals in these areas?
Yeah.
So basically what I propose is to use BIM, even though the employer usually doesn't want it. I don't know what are the conditions here in India, but I know that here in Poland, the customer usually doesn't care if you use BIM or not. But what I would suggest is to use BIM right from the start, even if it's just for you. If you do have this opportunity to use it. And then gradually introduce this methodology, these BIM models to your client, not as a strict rule that I'm either doing BIM or not doing anything at all. And you either communicate via models in terms of, you know, communication with all the participants, or you do not communicate with us at all. No, let's start with some simple things, with some simple presentations, with some simple coordinations using BIM models, just to introduce the idea, just to introduce the benefits that are really there, especially for the infrastructure, right? And what I would also propose is to get ready and patient, because the tools which are being used for model infrastructure in not perfect. And this is a common knowledge. I mean, both in terms of format exchange and in terms of the building of the models itself. Obviously, tools such as Revit, ArchiCAD, or Tekla, or I don't know, Vectorworks, were initially designed to conduct, you know, building designs, right? And so the tools which are being now developed for the infrastructure, this thing is a work in progress, right? Bentley has some really good solutions for the linear infrastructure, right? Autodesk is developing Civil 3D, especially this new development which connects Civil 3D to Dynamo, has some great potential. But what I would suggest is to be patient, to learn those tools, to find the tools that are really best suited for the project, because there might be different tools suited for the road design, and there might be different tools suited for the rail design, right? Also, the third most important thing I would suggest is to use the advanced survey methods when conceiving and when initiating BIM projects in infrastructure. So these three things I would suggest, and hope that you know, the rapid development of India will be hopefully conducted at least in part using BIM methodology.
Indeed. So Pawel, like you have been working in the GIS field, in the BIM and GIS field since more than 8+ years. So what do you see about the development and the implementation in different countries? Like what do you think? Like, do we have a proper a case study of implementing BIM GIS integration in any of the part of the world?
Well, you know, in Europe, for example, for sure the leading countries are the Scandinavian countries. I mean, Finland, Sweden, Norway, they are absolutely top of the top in terms of BIM as it is, but also BIM and GIS integration. The northern countries in Europe, such as Netherlands, are also pretty advanced in terms of GIS platforms. They are doing virtual city models and they are integrating more models into those platforms. But what I've seen in years, the most, I think, important trend is developing more and more reliable processes for creating both BIM models and GIS models. So these processes, formalized documents such as ISO 19650 or PAS 1192 from British standard, from Finnish standard, these are really helping to build proper models, but also to integrate them later on by proper IFC experts and so on and so forth. The second thing, apart from the processes which are being developed and which are better and better, the second thing is the development of the tools which are being more and more user-friendly and enable more and more fluent integration. A couple of years ago, we needed to export an IFC file from Revit, and we needed to access it through a different platform. The process we get in a platform, GIS-based tool, and only then could we interpret this IFC file in the environment. Nowadays, you can basically use just Revit and ArcGIS, so you do have proper coordinates. You just instantly connect those two environments. Of course, it still isn't, you know, as flawless as you might expect, as you want, because this is a database, so you obviously need to control the database, but still it's more and more user-friendly to do it.
Absolutely. So it's really commendable, Pawel. Like, we have learned and understood a lot of workflows related to BIM and GIS from you today. So
Okay.
thank you very much for joining with us today for this session and waking up so early in the morning at 8 a.m. So thanks a lot.
Thanks a lot. It was my pleasure once again. Bye then, and have a good day.
Thank you, Pawel.